Hey everybody, welcome back. This is lesson 4 in our unit, thermochemistry. In the last video, we covered the first of 3 heat calculations, the MCAT equation. And so, in this video, we're going to cover the last 2, the heat of vaporization, that's this one, and the heat of fusion equation, that's that one. They're less involved, and so we're going to kind of lump those 2 together. So, jumping right into it, the heat of fusion equation, again, all 3 of these are on the back of the reference table, so you don't need to memorize any of this, just know that they exist. But the heat of fusion equation, number Q, just like MCAT, is our heat, and that's in joules. Our M, just like MCAT, is mass in grams. And now HF stands for heat of fusion, and the unit for that is going to be J over G, or joules per gram. And so, if we're going to relate this back to the heating and cooling curve, like we did with the MCAT equation, that we use the heat of fusion equation when we're talking about anything that occurs on that first flat line. So remember, anything that happens on this flat line, this is freezing, and it's melting. So, melting. So whenever you're using heat of fusion, we're talking about heat freezing or melting something. So the way I like to remember it is F for fusion, F for freezing. So whenever you're talking about freezing, melting, something going between a solid and a liquid, that flat phase change, that is what we're talking the heat of fusion equation. And so when we're talking about water, we saw this table in the last video. Heat of fusion for water is given to you. So it's 334 joules per gram. And so again, if the question says we're dealing with water, they expect you to go back to table B. If you're not dealing with water, they will give it to you if it's a different substance, or that's what you're looking for. Okay, so let's jump into a question. And like always, I like to start off by writing our formula. And so I'll tell you why I know we're using heat of fusion, even though I know this is the section we're working on. I'll show you in the question how we know we're using that one. So what is the amount of heat required to completely melt? So the key word there is melt. Remember, on your heating and cooling curve, or if we do a cooling curve, melting occurs right there, that lowest flat point. And so that's how we know we need the heat of fusion. So heat of fusion is used for melting and freezing. So that's how we know we're using this equation. Q equals mHf. So Q equals M equals HF equals. And so what is the amount of heat? Remember, heat is our Q. To completely melt 200 gram sample, so 200 grams of water at STP. So again, we don't care about STP because we only care about that during our gases unit. And so these are all the numbers we're given. We have to remember heat of fusion, but the clue is that we're dealing with water. And so if we go back to table B, heat of fusion is 334 joules per gram. So 334 J over G. So that's where that unit comes straight from table B. So now we can kind of plug into our equation. Q again equals mHf. Oh, I needed that. Never mind. Q equals, erase this. Let's try it again. Q equals 200 grams times 334 joules per gram. And so our grams cancel out, we're left with joules. So that's how you know what unit we're going to be in. So Q equals 200 times 334, which is 66800. And our unit is going to be J. So again, we're including the units because it shows you how everything cancels out again except for what you're looking for. Very similar to dimensional analysis. So really, whenever you use an equation, all the units cancel out except for the unit of the thing you're looking for. And so that's it. Less involved equation. Now, heat of vaporization equation works very, very, very similarly. And the symbols are, again, basically the same. Again, Q is heat, that's measured in joules. M is going to be our mass in grams. Our HV is our heat of vaporization. Okay, so if we're talking about heat of vaporization, that's what that V stands for. We're talking about where vaporization happens on a heating and cooling curve. And remember, this is your condensation, and this is your vaporization. So it happens on this higher point of the higher flat point of your heating and cooling curve. So what I like to do to remember this is, well, V in the equation literally stands for vaporization. And so you use it during vaporization, or that part of the graph. So vaporization, condensation happen on the same part of the graph. So we're going to use those for the same thing. Okay. And so again, just like the last one and the MCAT equation in the previous video, if we're talking about water, table B gives you that value of water. Again, if we're not dealing with water, they will either give it to you or that is what we are looking for. Okay, so let's jump into an equation. And so what is the total number of kilojoules required to boil? So boil, that is our keyword that we're going to be using, Q equals mHv. So boil, condense, vaporize, all those words refer to the higher point of the heating or cooling curve. So boil is our clue. So we're going to use Q equals mHv, list it out. Okay, so what is the total number of kilojoules? So we're looking for Q. Needed to boil 100 grams of water. And at 100 degrees and 1 atmosphere. Now, in nowhere does our, in this equation, it doesn't have something for temperature. So the fact that we're given 100 degrees and 1 atmosphere does not matter. There is nowhere to physically put it in the equation. Now it says boil, so that's how we know we're using this one. So don't let that temperature confuse you and think that we're using a different equation. So those are all the numbers we're given in the question, but we're still missing heat of vaporization. And so remember, heat of vaporization for water is on table B, and so that's at 2,260 number. And so we do 2,260 joules per gram, and now we have everything we need to plug in. So Q equals mHv. Q is what we're looking for. M is 100 grams. HV is 2260 joules per gram. And so grams cancel. We're left with 100 times 2260. So Q gives us 226,000 joules. But the question is asking for kilojoules. So just be careful with what the question says. Remember, 1 kilojoule is equal to 1,000 joules. So what we can do is divide by 1,000, which is the same as moving your decimal point over 3 spots. So Q is going to be 226 kilojoules. And that is it. So that's pretty much it for these equations. They work very, very similarly. Just the keywords in the questions tell you which one you need to use. I'm going to leave it right here with your lovely meme of Dwight from The Office. But that's it. This is the last content video of this unit. Next thermochem video will probably be a review, and our next unit is going to be Unit 9, Kinetics and Equilibrium. So that is it. Have a wonderful day.